design our shear floor, it will look like this. Okay, and this is our element A, right? What I want you to show you. So if you look at element A, due to Vy, the shear flow is going towards the right, right? You can see that, right? The shear flow is going towards the right. If we look at Vx now, due to Vx is going towards the where? Left. So we are still looking at element A, right? So what it should be when we construct the element, we will come to that, okay? But let's look at this first, okay? So we know that the thickness is also equal to 11.8, right? And we know that Ixx now, right? So we go and look at Ixx. Our Ixx is 40.8 times 10 to the power minus 6. Right? So now the area we're going to consider is this area, still the same, right? But it's going to be what? So the formula, so the shear stress is still the same. Shear stress, Zx, right? So this is equal to Vy over Ixx Qx divided by T. Okay. So the first moment of area is about the what? X-axis. Okay. So we have interest in XX. So this will be our width, right? This will be our depth, right? So Qx is equal to width multiplied by depth, and the distance from here to here, right? This is our y bar. Okay. So the width is 75. The depth is 11.8. Now, what is the y bar? Okay, so we need to find D. So we look at the table, the D value is 0.205. Okay, so 0.205 divided by 2 minus by 11.8 times 10 to the power minus 3 divided by 2. Now, why is that? Okay, so we know the distance from here to here, right? This is where we get our 0.205 divided by 2. And then the distance from here to here, this distance that you see over here, is 11.8 times 10 to the power minus 3 divided by 2. And this is the distance of your y bar. Okay, so that's why we do that. So this will be equal to 0.205. 2 minus 11.8 power minus 3 divided by 2. 10 by 11.8 power minus 3 times 0.075 is equal to 85.491 times 10 to the power minus 6. Let me do it again. 0.205 divided by 2 minus 11.8 power minus 0.205 divided by 2 minus 11.8 divided by 2 times by 11.8 power minus 3 times by 0.075 is equal to 85.491. Okay, so this is in meter cube. So once this is done, we know that our shear Zx is equal to 25 times 10 to the power 3 multiplied by Qx is 85.491 times 10 to the power minus 6 divided by Ixx 40.8 times 10 to the power minus 6. And then we're going to have our T, which is 11.8. Okay, so this will be equal to 25 power 3 times 85.491 power minus 6 divided by 40.8 power minus 6 divided by 11.8 power minus 3 is equal to 4.439. Okay, times 10 to the power 6 Pascal, and now we know that the direction is different now. So this is due to your Vy, and this is due to your Vx. Okay. So now, finally, we are able to construct the element. Okay, we are able to for element A only for now. Okay, so now again, you can see, right, the analysis part was earlier. Now it's putting in the formula. The confusing part is the first moment of area. That's where we tend to make a lot of mistake. Okay, so then we I'm going to sketch element A now. Okay, so this is our transformation. This is our X. This is our Y. And this is our Z. Okay, so we are going to sketch element A. Okay, so this is our element A. Oh, sorry. So element A has a shear, normal stress coming down in the Z direction. Right, so this is our element A. Right, so in the Z direction, it's coming at sorry, it's tensile dopant 28.852. Okay, so it's 28. Times 10 to the power 6 Pascal. And then the shear stress, right? Now the shear stress is the conflict. So we know that 6.047 towards the left, right, is larger than 4.439 towards the right. So now you know the largest one is 6.047 is going towards the left. Okay, so you do this. Okay, so we know that this is our shear. So this value will be equal to 6.047 minus by 4.439. So this will be equal to 6.047 minus 4.439 is equal to 1.608 megapascal. Okay, so this is for element A. Okay, okay. So we can now I'm going to do element B. Okay. So if now we focus on element B, anyone any question? It's a lot of remembering the analysis for the first 6 weeks. I think that's a critical part in calculating the stresses. The forces is I taught you recently regarding the forces. Okay, so let's look at element B now. Okay, let's focus on element B. Okay, so again, stress X or Z of element B is equal to PZ over A plus by mx over ixxy plus by mz, mz, Eugene, seriously, my over iyz. Okay, so the first one, px over a, is a constant for all the elements. So what we calculate is minus 18.797 times 10 to the power 6. Okay, minus 18.797 times 10 to the power 6. Let me record it. 18.79. Okay. Then next we come to mx. Okay, let me give some space. Okay. So we look at mx, we calculate mx to be equal to what? To be equal to 22.75. But at element B, right, mx is equal to 0 the moment x is equal to 0. So we know that this is plus 0. And then my, because we did the element analysis already, right? Mx over ixy, okay, element B is at the neutral axis is equal to 0. That is the advantage of using a technique like this when you have done the analysis, okay? Then you look at my. So my is equal to what? 9600, and for element B is going to be positive. Okay, so positive, so plus by 9600 divided by IYY. So IYY is equal to 9.03 times 10 to the power minus 6. And sorry, this is XX. And on element B, X distance is this distance over here. Okay, so we need to find the thickness of the web and divide by 2. So thickness of the web, right? So thickness of the web thickness 7.24 millimeters. So 0. Divided by 2. Okay, 1, 2. No, it's 0. So 7.24. Sorry, 7.24 times 10 to the power minus 3 divided by 2. So this will be equal to minus 18.797 times 10 to the power 6 plus, right, is 9600 times by 7.24 power minus 3 divided by 2 divided by 9.03 power minus 6 is equal to 3.849 times 10 to the power 6. Let me do it again. 9600 times by 7.24 power minus 3 divided by 2 divided by 9.03 power of minus 6. 3.841, yeah. So minus 18.797 power 6 plus by 3.849 power 6 is equal to minus 14.948 times 10 to the power 6 Pascal. Okay. Minus 18.797 plus 3.849. 18.797 minus 3.849. 14.9. Okay. So that is the normal stress. So what I'm going to do, I'm going to stop here. Okay. And I'll continue the shearing stresses on Thursday. I'll see you guys then. Thank you. I'll still be around if you have any questions. Oh, someone have. I can't imagine how come. Yeah, yeah. It's a, yeah. That's why companies